Envision looking at the skyline and seeing the dawn fill half of the sky. Neil deGrasse Tyson popularized that creepy crawly squeeze recently detonated and something unnerving is occurring. Home to over 200 billion stars, our smooth-way universe is extensive and puzzling. However, there are minutes while it seems to draw us in with a compelling force. One such second is the present-day alarming exercises happening with Betelgeuse, a pink noteworthy enormous genius best 650 light-years away, situated on the left shoulder of the Orion group of stars. Betelgeuse is one of the most splendid stars in our detectable universe, frequently going through varieties in its iridescence. An ongoing vacillation in Betelgeuse's glow within shocking half markdown has persuaded astrophysicists that we are roughly to observe the definitive astronomical display. Researchers and space experts concur that the events happening with Betelgeuse are harbingers of the star roughly to head cosmic explosion. Anyway, the real timing of this event stays unsure. Betelgeuse's vicinity to Earth makes this alarming, since we should without a doubt observe an incredible change that few on our planet will at any point get to encounter. Betelgeuse, additionally referred to as Alpha Orionis, is for the most part the 10th most splendid star in the evening sky and the second most splendid star in the Orion group of stars, showing the tracker's right shoulder. This pink monster hotshot is exact among the extraordinary stars in Orion, which are much of the time splendid youthful blue Goliaths or great monsters. Along with stars like Rigel and the Orion cloud, it makes an outwardly beautiful heavenly picture in our smooth manner universe. However, Betelgeuse's situation in space science reaches out past its wonder since it has assisted us with breaking down more about the astral presence patterns of large stars. The distance across of Betelgeuse is multiple times that of our Sun. On the off chance that it changed our Sun-powered its floor could grow past Jupiter's circle. Its size way that we can see it with the exposed eye, and its variety contrast from different stars in Orion is noticeable to those with sharp eyes. Anyway, Betelgeuse sometimes movements up or down inside the brilliance rating because of its repetitive diminishing and lighting up. Regardless of being best 10 million years classical, making it 50 occurrences more energetic than our Sun, Betelgeuse has currently spent all its hydrogen fuel and is inside the later phases of its development, melding helium to carbon. Current data roughly Betelgeuse has been alarming, making sense of the fluctuation in its brilliance over the past 2 or 3 years. Cosmologists have found Betelgeuse's brilliance to wax and wane on a normal multi-day cycle for many years. However, in December 2019, the mega-star sort of became 2.5 cases fainter than previously found, a half decrease in glow. This outrageous decrease prompted researchers to theorize that something unnerving is approaching inside the large name. This last occurrence of diminishing, now known as the momentous darkening, transformed into not set in stone to be because of an enormous material blast from the stars inside, bringing about a colossal residue cloud that obstructed our view. Betelgeuse has not gotten back to its old-fashioned self, taking into account that the residue cloud evaporated. The star's multi-day brilliance wavering cycle has been reduced in 1/2 to 200 days, and beginning in the spring of 2023, it became more brilliant than run-of-the-mill at its top brilliance. These changes have driven most scientists to settle on the opportunity that Betelgeuse will soon cross cosmic explosion. Cosmic explosion blasts are huge stars' closing moments. Red monsters begin consuming carbon and oxygen into neon and magnesium, then consume those into silicon. After the utilization of up all of the helium in their centers, the offices of the famous people sooner or later develop to be iron-rich and including helium cores to an iron iota remove strength and inclination to liberating it as an outcome. The big name's course begins to develop to take in energy, prompting a center collapse. Cosmic explosion blasts can, to sum things up, surpass whole universes due to their outrageous brilliance. Betelgeuse's cosmic explosion blast due to its nearness could be energetic to the point that it would be seen over the day at only 650 light-years away. Humanity is impeccably situated to witness this enormous occasion. A huge VIP like Betelgeuse detonating will create a beautiful demonstration of gentle that could arrive at 100,000 examples, the equivalent old iridescence of the star. At first, there can be an astonishing inflow of neutrinos, noticeable via observatories worldwide. The gentle delivered could result from high-power photons getting away from the quickly expanding haze of star particles, matching the brilliance of a full moon. Because of its vicinity, Betelgeuse is one of only a handful of exceptional stars that can be examined all the more intently through telescopes on this planet and in circle. In sync with zenith hypothetical astrophysicists, beside our Sun, most stars can't be explored in any profundity. We most viable word them as single marks of light. However, Betelgeuse is sufficiently enormous for the Hubble Region Telescope and Radio Telescope to clear up. These photographs show an enchanting body that is extremely dissimilar to our Sun. Betelgeuse is certainly not a solitary straightforward circle of exceptionally hot plasma. Rather, it is a knotty group of foaming fuel that radiates standard Cs TFTS of warm material that is sent to the surface previously or cooling and getting back to the inside. Scarab-Ju has a very even photosphere, the outer layer from which gentle is transmitted. However, its photosphere showed perfect unsettling influences and changed into expanding at a normal rate until mid-November 2019, while the outward VC began to reduce while the surge of material from Betelgeuse halted. Cosmologists caught optical photos revealing new peculiarities. The southern hemisphere of the superstar showed a newly molded obscured region, and its surface temperature had dropped with the guide of 80 Kelvin. These changes were apparent to telescopes, and the eye focused on perceptions with contraptions very much like the circle on ESO's extremely enormous telescope confirmed an extraordinary decrease in brilliance through a part of 2.5, accomplishing its most minimal recorded brilliance with a worth of in addition to 1 nearly 12 months after the surge suspension. The well-known individual recovered limit of its first glow. Stargazers suspected that a gigantic residue cloud blocked the gentle produced from the big name. However, further assessment couldn't show this theory. That's what one more proposed theory was: Betelgeuse, a variable celebrity showing brilliance varieties over time. It went through a succession of throbs or then again, hazards in its outer layers causing the brilliance substitute. This speculation transformed into upheld by the presence of enormous convective cells on the star's floor, very much like the ones in a pot of bubbling water. The exact timing of Betelgeuse's blast stays uncertain, with different expectations from the clinical local area. Betelgeuse, a red astonishing monster genius set inside the Orion heavenly body, has been a subject of extraordinary critique and look because of its enormous varieties in brilliance and its ability to go cosmic explosion. Betelgeuse's unusual lead has achieved various speculations about its future. A couple of specialists propose that creepy crawly juice is approaching the finish of its carbon-consuming fragment. This detail is significant in a star's life cycle and implies that it is approaching its absolute last stages. When a celebrity debilitates its carbon fuel, it gets going advanced to consume heavier components till it in the long run amasses iron in its center. At this variable, the center can't create energy through combination M to a disastrous go to pieces and resulting cosmic explosion. Assuming Scarab-Juice is surely approaching this degree, it can imply that we are on the mark of seeing one of the most amazing occasions in our cosmic system, the death of an enormous large name. However, different researchers consider bug juice remains inside the early art of its development. With regards to this perspective, the star has a few centuries left before it debilitates its gas and undergo a cosmic explosion. This perspective is based absolutely on models of heavenly advancement that think about the confounded cycles inside Betelgeuse's center. These models recommend that bug-Ju might still be consuming helium, postponing its change into a cosmic explosion by millennia. Adding to the vulnerability, researchers at Harvard College have speculated that the cosmic explosion blast of Betelgeuse ought to be many hundreds to 10 billion years into the future. They contend that Betelgeuse keeps on being consuming helium at its center, a stage that goes before the consuming of heavier components like carbon, neon, and oxygen. Consistent with these researchers, creepy crawly Ju has not yet arrived at the critical component where an iron gathering would cause a cosmic explosion. This expectation is based absolutely on contemporary hypothetical models and observational measurements. However, these models have inherent vulnerabilities. The debate over the timing of Betelgeuse's blast features the intricacies of heaven development. A star like Betelgeuse undergoes various changes all through its lifetime, impacted by factors comprising of mass, structure, and interior strategies. Anticipating the specific course of events for these changes is hard, specific for a star as huge and variable as Betelgeuse. Most recent observations have brought renewed interest in Betelgeuse. In December 2019, astronomers noted a significant dimming event where Betelgeuse became 2.5 times fainter than usual. This event sparked numerous theories, including the possibility of a large dust cloud obscuring our view or intrinsic changes in its outer atmosphere. Such observations provide crucial data for understanding how massive stars behave and evolve as they approach the end of their lives. The potential for Betelgeuse to undergo a supernova explosion is another aspect that fascinates scientists. Supernovae are some of the most powerful explosions in the universe, releasing vast amounts of energy and creating elements essential for the formation of new stars and planets. If Betelgeuse were to undergo a supernova in the near future, astronomically speaking, it would likely become visible even during daylight and could shine as brightly as the full moon from Earth. Studying Betelgeuse's variability and anticipating its future evolution involves combining observational data with theoretical models of stellar physics. These models help astronomers predict how stars like Betelgeuse will behave as they progress through their life stages. For instance, scientists use computer simulations to simulate the internal processes of stars, such as nuclear fusion, convection, and mass loss, to understand how these processes influence a star's evolution towards a supernova. Furthermore, Betelgeuse's proximity to Earth makes it an ideal target for detailed study using both ground-based telescopes and space-based observatories. Instruments like the Hubble Space Telescope and upcoming telescopes such as the James Webb Space Telescope enable astronomers to capture high-resolution images and spectra of Betelgeuse, revealing intricate details about its surface, atmosphere, and any ongoing changes. Betelgeuse represents a crucial case study in the exploration of stellar evolution in supernova physics. Its unique characteristics, including its size, variability, and proximity, provide valuable insights into the life cycles of massive stars and the cosmic processes that shape our universe. Continued observations and research efforts will undoubtedly enhance our understanding of Betelgeuse's behavior and evolution, paving the way for deeper insights into the broader field of astrophysics and cosmology.